when you get time, you actually start, you have the ability to actually create your own packet tracers or do customized packet tracers for your students. I've had, I don't know, he's not on here, but Kirby Simerson at Randolph Community College does a lot of custom packet tracer items. He does it for every packet tracer that Cisco has. He'll go back and modify each one of them and then have the students turn those in instead of the ones that they download from Cisco. If one updates, he'll update that packet tracer to fit his needs. And a lot of it, he was one of the first ones I realized it only allowed the physical interface, didn't allow the logical interface in packet tracer, which was good to go ahead and start doing. And then when Cisco started moving over to that, it's his students were already well aware of that. Let's see, any problems? Any Alexi, no, you won't need to save anything in NetLabs. All your keystrokes are saved by default. You'll just need to turn in documentation. So you'll go to the instruction document that you use for each lab. Download it from within NetLabs. Don't use the one that's in Netacad. Any labs that are aligned with NetLabs, download that one as a PDF and then convert it to a Word document, and then you can edit that Word document and upload that for grading. All right. It seems like that's everything. I am recording, so. All right. So today, one of the things Kelly asked me to go over was module 3. Let's go back into module. He actually asked me to go into module 5 and start working with binary numbers and hexadecimal numbers and those items. But before I do that, I just want to go over just some reminders. All of the Zoom sessions will be recorded, and then we will place the recordings here. They're all going to be uploaded to Kelly's YouTube page, and then you can just select it and watch it either in here, or I think it may even let you go to YouTube and open it up in full screen. For anyone that doesn't make the meetings like Monday and Wednesday, it is a requirement. So if you miss a day, you can always go back and watch them. I can't say that I cover everything in full detail. We're going to miss some items. What I definitely would like everyone to do is feel free to speak out. Turn your mic on if you have a question. We're going over something, something doesn't make sense. Ask us, because ask us then, and don't wait, because it's easier for us to answer it now than 2 hours from now when we might get a chance to look at email. Sometimes it's easier for us to answer now. Requirements for this week. So everything in module 1 through 3, okay? And again, you're only required to do 80% of all the labs within this course. So you can pick and choose 80% of the labs you want to do. But everything in modules 1 through 3 that you decide to turn in or do this week, or actually do today, along with the module 1 through 3 exam. Monday, I went through and I verified that I had everybody activated in the exam. So if you have any issues and it's not activated, please let me know. Question. Earl, labs are not in NetLab or packet checks actually to turn in or to show we did the. I'm not quite, the ones in NetLab that aren't in NetLab, those will be, I think, first, like this one, that's fill in the blank. So you don't have to turn that one in, but it's a good one to look at. Ones that aren't in NetLab or not a packet tracer, you can still turn those in if you want to. But what we've decided is these are the ones that we see as relevant right now. The other ones, yes, they're important, and you can have your students turn those in. It's just if you look at the entire course, we've already got a bunch of items that are required to be turned in. So we didn't put every single lab or packet tracer here. However, if you want to fill it out, and you want to say, can you look this over and make sure it's right, even though it's not here, you can email it to your instructor and we'll go over it. All right, so how to save a packet tracer. Let's open a packet tracer. Also remember that you can go directly to the packet tracer here and download it, but until you open up the course reading material, it will give you an error and it will like time out. So you'll have to go into the course reading material here. Once you've opened that, then you can go back to the first packet tracer, whichever packet tracer you're doing, and then you can use that link. And then while you're there, then you can download the actual packet tracer. Okay.
Brian, my question is, after I do I go through the packet tracer, and when I'm finished, do I do file save as?
Yes.
Well,
Yep.
that's, I mean, I started one now and I had to stop to come into class, so.
You can save the packet tracers and open them up later to work on. I mean, they're not gonna, wherever you save them, they're gonna be ready for you to continue on wherever you're at.
Cool beans, because I've been starting over.
Yeah, you don't have to start over.
So when I say save as, it goes to my download folder and then I go to the link and submit that link?
Yes, that's exactly right. I'll show you where. So, all right, so this packet tracer, sometimes a packet tracer will open up where you've got the instruction sheet and then the actual topology. I always just go to doc and it puts the instruction sheet inside the packet tracer there, and it's all kind of in one. And like I said, you can just go file, save as. It'll save it as a PKA, save it with your name, either in front of it or after a 3.55. Save it to a location that's relevant to you and you know where to find it in your folder structure. And if you halfway through it, save it, you can close it and then come back up and it'll be saved there. So don't redo any that you don't have to do. Once you've saved it, and this is 3.55, it is going back into the course. And then you just, I don't have the option. Let's see, I might fucking beautiful stuff. So if I go to 355, then I just add the submission here, save it. I can drag and drop it and or select files wherever it's at, and then load file. And I can just upload the file like that and then save the changes. And now it has been submitted. If there's anything you want to add after the file submission, you can do comment. You can add, this is a test comment. You could add anything you want. I have problems with such and such section. Please help me understand why I didn't get the full percentage of the packet tracer. We will give you the grade, and then beside that, let me get out of this as a student. When I'm grading, I don't think anybody's graded done yet. Let's see. Some. Sorry. Edit home. So when either me, Kelly, Michael, whenever we grade, we can actually go into the grading here. We'll input your grade and then any feedback you have with it. If you didn't get 100% on the packet tracer, we'll put the comments in there for you after that. Let's see. All right, what other question?
Hey, one more. When you were opening that book up, you showed how that I can embed directions.
The directions come out in the submission.
No, when I open it up, it comes up and then the directions come up and I have to log back in. You have it all in one.
Yes, that's just the doc here, the DOC.
Wait, okay, can you point to that one more time?
Yep, it's this right here, right beside the check results, the doc right here. So when you
Okay,
select
thank
that,
you.
The other thing that make yourself familiar with, and this is for everybody, use this check results here. Sometimes it will be open and available, but sometimes the assessment items will be this link right here, and it'll show you every single thing that's being graded in the packet tracer. That helps you tremendously. Like this one, unfortunately, this one didn't have anything to really configure. This was just another like training how to use packet tracer, how to view TCP HTTP traffic here, switching between the real time and simulation mode. The real time, you just select the device and you kind of see what's going on. The simulation mode is if you hit play, let's see, edit filters. You can edit which filters you want to see. So if I wanted to see R, DHCP request, OSPF, actually I can edit those filters, but I'm not. And then if you were to send let's see, what's the IP address? So if I go to web clients, you go into desktop, browser, just go to www.osi.local, then go. You actually, between the simulation and the real time, you don't see the packets actually going from point A to point B, but in the simulation, you can actually watch it go from the web client, the HTTP web request from the web client to the web server, and then the response. So that's good to know and good to see. What are the passing scores for us on the exams? In recommendation, yeah, it says 75%, but I like 80% because 80% is kind of mine. If this was a curriculum class, I would say 100% because you get multiple attempts. And if for an ITC instructor or for you to take in this class, I wouldn't be happy making less than an 80. I'd want to redo it just to make sure I understand.
Thanks.
Go ahead.
I said, thank you.
Okay. Lorraine, for whether you're on module 1, 2, or 3, it doesn't matter to me. I want you to be comfortable with your pace. If you're a little bit behind, you can catch back up, no problem. The exams, we've opened everything in this course up from day one. So you'll be able to see any exam you want to take and then take it as many times as you like to get the best grade you choose. So
I have a
don't
question.
be ashamed to be behind. Go ahead.
When you take the exam, I took it twice already, but how do I know which answers I got wrong? I got the 80th percentile as you expected, what you guys are looking for, but I want to do better, but I don't know which one I might have failed. I don't know how to go back to it. Yeah.
Is this Michael?
Yes, sir.
Okay. Let's see.
I just looked at this today, so I can chime in if it helps. There's at the assessment results screen, you'll see 2 different links. One's like personal feedback report and one is item feedback report.
Yep.
You can click on item feedback report, and if there's any feedback for you on which ones you got right or wrong, that's where you should see it.
Oh, okay. So it tell me what I got, which question I got wrong, or the category of the question I got wrong.
When I looked at the personal feedback report, it seemed to only tell me the category. When I looked at the
Okay.
item feedback report, it gave me the specific question I got wrong, and it happened to be
Oh.
one of the multiple choice answer ones. So it told me specifically which answers were correct.
Okay, I'm thinking I got the multiplication, the one that you have to choose, the arrow 1, 2, 3. I think I know I got that one incorrect, and I couldn't figure out which way it goes. So
All right, so when I look at, and here's what she's talking about. Thank you for that, Jessica. You've got personalized feedback. You select it, and it kind of tells you which areas that it is. Item feedback. Yeah, you'd have to run 7.22 and older. Take a minute.
go back to my exam. Which one is the one? So you say go to the assessment history or the retaking? What option did you say? I'm sorry.
You had the personalized and then the item feedback.
I don't see that option. Am I looking at? I'm looking at it now. I'm looking at what I see is my score and retake assessment and history.
All right, so I'm gonna turn on screen sharing if you want to share your screen. you're more
Yes,
than
sir.
welcome to.
If you see your score, you should be able to click on your score.
Oh, okay, I got you now. Go ahead, click on my score, and then
You should see the category and the item feedback
Right.
once you click on your score.
Okay, I got that. Oh, I see the personal feedback. So that will be the item feedback or the personal feedback to give me the information I'm looking for. Oh, I see it now. Okay. Thank you so much. I couldn't figure this out. So I really appreciate that. Now I know exactly what I did wrong. Okay, good. Thank you.
Okay, Lorraine, not Lorraine, Dr. Reynolds. Yeah, what to submit is the completed packet tracer and then a screenshot of the overall grade. That's for the packet tracers. For the labs, all we need is the document that you download the PDF and then close the PDF and then open Word and open the PDF inside Word, and then you can edit your information. Here. All right, any other issues or anything for module 1 through 3? All right, so let me kind of just do this. Talk about internet connections. When you went through modules 1 through 3, how much time did you spend on the module quizzes? These aren't graded for us, but they're it's good information to go back and practice. Here's the summary of each of the module. This is module 1, the summary of information, and then these module quizzes. Did any of you try that? And what was your thought process on the quizzes? Please.
I went through, when I went through the modules, I definitely took those quick questions at the end just to get an idea, the feel for the students. So I did that part for sure.
Okay. The reason I bring those up because these are very similar to what questions you would have on the CCNA certification exam. Some would be in single question or single answer. Some would be multiple answer, like here, which two. And then the other thing they didn't put in here, they'll even have some questions, which one is incorrect. Instead of choose two, it could give you five answers and you pick the one that does not match. So that's the reason I recommend doing the end of the module quizzes, because one is for summary verification, the material that's covered in each of the modules, and then that's just a quick 15 question check with. All right, is everybody okay with going through, starting with module 4 and just kind of talking about it? Or do I need to cover anything in modules 1 through 3 again before I move on?
Oh, I got that one wrong. I said, oh, I'm talking to myself. I'm sorry. I put myself on mute.
Oh, that's all right. I talk, as long as you don't answer yourself, we're good. So. All
Hey,
right.
if you talk to yourself, you're having an intelligent conversation.
I don't know. My dad would disagree with that, but all right. So introduction to module 4, physical layer. Physical layer, go for 4, physical layer. We should be able to see it. Do you see my screen, by the way? Okay.
Yes.
The physical layer is where a majority of students in NetAcad miss out. If you're only teaching with a packet tracer or you're teaching online, students aren't putting their hands on cabling, and they're not putting their hands normally on even on equipment. I always represent the physical layer is normal. When I was in IT, that would be where I would start. I would start at layer 1 with troubleshooting, and then kind of work my way up to the OSI model or TCP/IP model to figure out what was going on. A lot of times when I was working on the help desk, no, I could not physically go to someone's office, but that's where I would have an individual on the other end of the call when I was doing trouble calls. Always check the cable. Is it just loose? Can you pull it out? And then do you teach this stuff to CS student? What is CS student? Can you update me on that, Dr. Reynolds? Or computer science? No, I don't. I don't. Others might, because the content here is for the CCNA. It can work with any degree. And what we're seeing is the CCNA and learning the technology and the network side of networks can help any degree field now, because basically no job out there, you're not going to have some type of computer understanding. And the more you know to help with that, makes you a better employee. So I wouldn't say there would be doing that. Computer science folks versus IT. Because I'm at a 2-year college, and John, you can reference this too, but John worked with us at Stanley. I always represent computer science is more theory, and when the IT field is going to be more hands-on. A lot of schools like ECU, when they're doing their 3rd and 4th year for their bachelors, in Fort Hays out of Kansas, they use the Cisco CCNA stuff and CCNP for their bachelor's degrees. And then they take credit for the CCNA courses. All right, so kind of back to the physical layer. What we're going to talk about is the purpose of the physical layer, characteristics, copper cabling, UTP, unshielded twisted pair, fiber optic, and wireless media. This is very relevant, just this module right here, because of Skills USA next week. We'll have probably about 45 contestants who will be working at the physical layer, plugging in gear, configuring devices for end-to-end connectivity, just in our internetworking contest. And then we have a telecom cabling contest. I think there's 20 or 17 or 20 students in it at nationals, and that's all they'll be doing is layer 1 configurations with each of these, whether it's copper, fiber, wireless, whatever it is. The purpose of the physical layer basically is direct connection. It's that physical connection from endpoint to endpoint. It could be from your computer to a switch, from a switch to a router, just wherever information goes across that a line from point to point is considered the physical connection. This talks about a wireless router. Your physical connection would come in from the internet to here, and these points or ports out to whatever devices are near. With this particular wireless router, this is a Linksys device. Here you've got 4 Ethernet ports, 1 internet, and a wireless antenna. That's just the connection for it. NIC cards for laptops. You will sometimes have some of the newer laptops will not have an RJ45 network connection with it. So you'd have to have a USB, and I don't have my USB with me. USB port.
Hey, Brian, I've got something, I think what you're looking for my laptop.
Yeah, this is a class USB-C, but it's got HDMI, it's got others.
Yeah.
It's even got an SD card reader, VGA. This one doesn't have an RJ45 connection, but I do have other parts to my laptop somewhere, because my Surface Book does not have an RJ45 connection. But I can use either a USB or USB-C connection with it to get that network connectivity. All right, OSI. We'll get more about the OSI because we'll talk about layer 1 of OSI here, layer 2, layer 3 will be in module 6 and module 7. But it basically, the physical layer provides a means of transport of bits or data from point to point. Here, you can see web server data, the web client. If I select play, you can see the web traffic being requested from the web client. Okay, the web client is going to request the data from the web server, and then the information from the web server is going to be sent back to the web client. But as that data is sent from the web server to the web client, the data itself is encapsulated, so the data does not change. It adds a TCP segment, whether it's TCP or IP. It adds the internet or the IP address information in it, and then at the Ethernet layer, it's going to convert it to ones and zeros. So that entire process took from the data down to the Ethernet level. Well, it encapsulated that entire packet into that. Characteristics. A lot of different characteristics and a lot of different vendors work at layer 1. Could be the cabling, whether it's a Cat5 cable, Cat6 cable. Is it a fiber? What type is it? ST, short run type fiber, long run type fiber. You have different manufacturers, but you have organizations that create the standards for those organizations or for those companies to follow. That way you have multiple manufacturers can build technology or build that physical layer component, and they're compatible with other products or other switches, other servers, routers. For example, we've got majority of our stuff is Cisco at our school in our data center, but our backbone is all Dell switches. Well, if it's layer 1, I still can, on the Dell switch, I can still use Cat5 or Cat6 cable, or I can use fiber connection, and it works between a Cisco device and our Dell switches. Take it a step further than that, we're actually using Cisco Meraki from our IT department. So we have very good interoperability with the product themselves. So the physical layer is implemented at the hardware layer, and it's governed by the ISO, EIA, TIA. And each of those organizations, here's the acronyms, but here's the full name of them, whether it's the American National Standards Institute. They all have a purpose, and their purpose is to make sure that if you're going to build a product that works between the physical layer and the data link layer, or the data link layer up to the application, it has to follow certain standards. That way, it can multiple hardware vendors can work together with different servers and things like that. All right, encoding. Encoding basically converts data to either zeros and ones, and they are it's the only way a computer talks: zeros and ones and zeros. We'll get into ANDing. We'll get into how network addresses are configured, how a router will know what route to route certain traffic through which port stuff comes on. Also going to talk about different here with the different speeds. So Ethernet, which is copper cabling, is either 10 base T, that's when it represents at 10, that's 10 megabits per second, goes up to 100 base T, which is 100 megabits, and then 1000 base T, which is a gigabit speed. Now we're into 10. Yesterday or Monday, when Kelly was at Cisco Live, which he's still there now, he was showing on an email he had sent us. Actually, Cisco's working with 400 gig connection now for backbone. So we have 10 gig connection in our backbone between our all of our servers in our data center, but they're working on 400 gig and more. And I think it's 200 gig maybe. They're getting speeds with fiber optic. No, excuse me, with copper now. Fiber's so expensive. Copper, the cheaper way to go. Copper's going to last longer, and that's just kind of where they're really focusing a lot of it. So the voltage, this is electrical signal over copper cable. You can see how sporadic it is. Fiber optic, it's going to be using pulses of light. Whether, and we'll get into more about it, but copper is just a voltage, fiber, a light, and wireless is going to be an AM, FM, PM, or a digital signal that goes across. Bandwidth. So we talked about a little bit about bandwidth, but you will see this in a some type of question with Cisco. Bits per second, 1 kilobit or 1,000 bits, megabits per second. That's 1 million bits per second. Gig is a billion, and terabytes is a trillion. And then they go off tens of what power bits per second they are. So a lot of it you'll be working in. We do work with still with a lot of megabits, and that's going to be with the fast Ethernet connection ports. Those are going to be 100 megabit. But a majority of what you'll be doing is gigabit or better. Not necessarily terabits. We talk about terabits in data storage. Most of the time it's gigabits in network bandwidth and stuff. Bandwidth terminology, 3 of them: latency, throughput, and good put. All right, well, I pronounce Ethernet as Ethernet, Brian. I don't know, my Southern slang, I guess. I guess that's just the way I pronounce it. I wish it was an in North Carolina State thing. I went ECU, so blame ECU on that. So, all right, latency refers to the amount of time, including the delays, to travel from one given point to another. Throughput, that means how fast traffic is getting from one location to the next. And then good put. This is a measure of usable data that goes across a network from point to point. Throughput would be the amount of traffic, type of traffic, and latency created by it. But I always kind of look at good put as what kind of speed am I getting down, and am I having any issues with bandwidth? It's just, it may say that I've got 80 megabits download, but it's just not working right. So that good put, yes, there's some questionable wording there. That's just how Cisco references that. I don't have any copper cabling at home, but characteristics of copper cabling, it is the most common. You will see this in a lot of wiring closets, in racks. You'll see fiber, and normally, and I would like to say fiber is more at the top of the a rack or data rack, because you want fiber out of the way. You don't really want students to be able to. For us at Stanley, we try to not have our students mess with too much fiber, especially if it's already in place. Copper, you can unplug copper, move it from area to area, and it's kind of hard to mess up ports. Now, leave it to a student. A student can mess something up very easily somewhere, somehow. And we've actually had students that will get dust on just on a RJ45 connection, not sure how it is, and they plugged left that dust on that RJ45 connection and actually shorted out a port on a Cisco switch. So we'd have 24 good ports on the switch, and now we only have 23. Normally, it won't mess up the entire switch. It would just be that port. You just have to kind of put a blank cover over that port, knowing it's no longer valid. That is excellent. If you have a switch like that, that is an excellent troubleshooting tool to give a student. Tell them to use that port, configure that port, and watch them squirm because they can't get they can't get network communication across. And it takes them a little while to troubleshoot and realize, hey, something's wrong with that port. But that's a life lesson they will never forget. I promise you. Dan, everyone, why not copper? You have fiber in the walls. We don't have fiber in ours. We have a lot of copper. We have fiber from building to building. We just had new fiber runs for our building. We now have dual or double redundancy now from our IT department to our data center, and then to our offices. We only have copper connections, the 1 gig for all of our offices. Let's see. My puppy's messing with me, so I'll show it to you. Let's see. Data transmitted on copper cables is electrical pulses. You can use a detector to determine speed, distance of the network copper cable. We've got some really good fluke testers. So we'll have students make copper cabling, whether it's straight through crossover or even a console cable. We'll make them do one of those. Either type standard A, 568A, or 568B standard. We'll get them to make multiple cables. EMI, not really, you don't really have any EMI interference or RFI interference with copper. You don't really have a lot of crosstalk with copper. Let me rephrase that. Yeah, he's kind of nervous right now for some reason. You do get EMFI and RFI interference if you have a copper cable laying over top of a fluorescent light. In our building, we've got drop-down ceilings, and we probably got a 4-foot area between the drop-down ceiling and our lights and to the top of the ceiling in the building. And if you pop one of the tiles and go up there and look in that section of the roof, you're going to see cabling go across it. In our building, for us, even though we're in technology, we're not going to see a big enough difference with interference there. Now, if it was a hospital or data intensive location, you would use shielded cabling. And then if it's something like that, you would actually want to use fiber because you wouldn't want any type of interference going across. Let's see. That just shows, and I'm not sure why that's there. So either I've got an issue with my screen or Cisco's got a problem with their figure there. I'm not sure. I guess this is noise and interference showing you. So the 4 that is showing here is a pure digital signal, which is transmitted. It's clear up and down, 1s and 0s. Section 2 or item 2 is some kind of on the medium side. You do see there's an interference signal. It's causing distortion in the signal. 3, this is a digital signal, but you can still see it's going, it has the up and down, but it's being corrupted by interference signals. And then here, it's such a bad interference that it's actually changing the 1s and 0s. You definitely don't want that. So if you're in an area where high fluorescent and high EMI interference is possible, then you definitely, copper would not be your way to go. Fiber would be the best way to go. So UTP is easiest to work with because it's the unshielded twisted pair, because it does not, it just has, if you were to remove the sheathing here, you'd have these 4 pairs of cabling, 8 pair UTP cable for RJ45. They're easy to kind of unravel and make and crimp RJ45 connections on them. Shielded twisted pair is more difficult to work with, but it reduces EMI and RFI interference. You can tell it's still got that. It's got a shielding. It's got a copper a plastic protection here that holds each one of these copper pairs in it and keeps them separated. And then you've got a full shield around all 4 pairs of cabling. And then coax, you've got the interclad, the copper here, the signal, and then you've got the outer coil and protection for coax. So that's for coax cable, that's the way that's done. UTP, unfortunately, we're not in the seated class. We can't have you make cables, but if you've never made a straight through or crossover cable, either 568A or 568B, I do recommend doing that at your school, practicing it, because you do want your students to at least have the opportunity to take the shield off, take the outer jacket off, and then you see each of the 4 pairs and how they're twisted together. Have a student unwind each pair. For you, it shows the student, if you can do it, it can be done, and then you'll see how much physical dexterity you have in your hands. I've lost a lot as I get older. It's getting worse and worse. Yeah, students will cut themselves. I agree. If somebody's going to cut themselves, it's probably going to be me. I'm a big klutz. I was even walking just down the hall and found a way to cut my arm today, just walking down the hall. But students do need to practice that and use that. STP, shielded twisted pair. You've got that outer jacket, the braided full, and then got the full shields, which the full shields are basically individual wrapped around the double pair or the pair of copper cables, and then you've got the twisted pair cables. So blue, white, blue, orange, orange, white, green, white, green, brown, white, brown. And that could be a different color based on the manufacturing, but that's the majority of what is the color cabling of it. In coax, you've got the outer jacket, braided copper shielding, plastic insulation, and then the copper conductor here. So if you're looking at it face on, this is what it looked like, and then the type of coax connector. You got the BNC, N-type, and F-type connectors. All right, properties of UTP, UTP cable. Let's see. They don't shield well with EMI and RFI. Designers, when the first pair came out, or the first UTP cable came out, it's just 8 straight wires. Then they realized they could twist the color, 2 of them together, and it helps with magnetic interference. And by twisting them, it cancels out any other magnetic or EMI or RFI signals around it. Here it says a varying number of twists per wire. So a UTP cable must follow precise specifications of how many twists or times it's twisted or braided for every 3.28 feet. And I'm not sure it shows that anymore. But you don't want it to the point where it's actually tearing that shielding, or it actually could be damaging the actual copper itself. All right, so cabling standards. You're going to see not really a lot of Cat 3 anymore. It's mainly Cat 5, Cat 5E. Category 5 cabling is going to support up to 100 megabits. Cat 5E supports up to 1,000 megabits or a gig. Cat 6 now is up to 10 gigabits per second. Cat 7 is up to 10 gigabits per second, and now category 8 is up to 40 gigs per second. Next week at Telecom Cabling, I think they'll have contestants do 5 actually Cat 5E, 6, 7, and 8 don't have to make cables or crimp correct RJ45 connections on both sides of each cable and to a certain length, and it's got to have no breaks in any of the wires. So they'll test that next week. And this just shows you what a Cat 3 looked like. And again, Cat 3 was just straight cabling, wasn't twisted. Cat 5 and 5E, this is where they brought in the twisted pair. And then Cat 6 is the STP, shielded twisted pair, where they got that full shielding around each twisted pair. Here's an RJ45 connection. That's just the connector. And this is what the end after it's been connected. You can't really see it too well, but you can see the cables as they have been inserted into the copper connector and then been crimped for completion. We have these in our, actually in our classroom now. We've got RJ45 UTP sockets and punch downs. We've got at each station in our classroom, we've got 3 connections that go back to our racks that are in our classroom. And then we've got the racks where they connect over each. We have 4 racks in our classroom, and then each of those racks connects to each other. So a student can be working at PC1 and then have equipment over in rack 4, and they would connect to whichever port it is at their station, and then connect it over at rack 1, and then run that cable up to rack 4 cable, and then at rack 4 run it down to the equipment. So these have been very beneficial in our lab. Okay. This right here, if Jeff Swearingen was on here, he would just take the end of it. And Jeff works with us at Stanley. John knows him. If a student were to bring him a cable that looked like this, yes, the cables have been inserted correctly, but they did not have the shielding or the copper clad shielding far enough inside of the connector and crimped correctly like this one is. He would take a cutter and right here, he would just literally snip it, give it back to students, says redo it. We've had students that have taken all 2-hour classes just to get one connector done. But you see, that goes back, for me, it's if a student doesn't get it done the first time and doesn't get it right the first time, they may give up on it. And you don't want that. When that student struggles for a minute and then figures it out and gets it done correctly, it kind of gives them that peace of mind and then makes them feel better in class. All right, straight through versus crossover. So 568A or 568B. This is a preference. It doesn't matter which one. But if you have a straight through cable, you're going to have the cabling done. If you flip the Ethernet plug on its back sides, basically, this would be pin 1 to pin 8. You would just basically plug them in, just plug the cable, you unwind them, straighten them out, insert them into the RJ45 connector in this correct color coordination order: green, white, green, orange, white, blue, blue, white, orange, brown, white, brown. For a straight through cable, they can be the same on both ends. So which if you run 568A or 568AB, whichever standard you run, they have to, for a straight through, it would be the same on both ends. Point from, if you make a cable that has a connector on one end and a connector on the other end. If they say crossover, it has to be 568A standard on one end and 568B on the other. Why do you have that? So you connect and use the correct type of cable. Before 2960s, X's, I believe it was, and the newer routers, Cisco switches, you could not get a straight through cable to connect a router to a router or a router to a switch. I mean, it would work that way. You get a straight through cable would connect a switch to the network device. Yeah, so unlike devices, you want to use a straight through device, straight through cable. unlike devices using straight through cable, like devices, whether it's switch to switch or router to router, you use the crossover. Now with auto crossover and availability in Cisco switches and routers, it will automatically, it doesn't matter if you use a straight through crossover, it'll use whatever cable is there. Rollover, it's basically, you'd have pins 1 through 8 here, and then it would go other end, be 8 through 1 here. It's completely, just complete opposite. In their design, basically it's a console port cable. So it's that light blue cable in the packet tracer where it goes from the console port or the DB9 port on the back of a laptop or a PC over to the console port on the switch or router. This is real good. The activity cable pinouts, which one goes where for 568 or 568B. That's real good. Fiber optic. I know we're getting close to time. This course doesn't get too heavily in fiber optics. A dog tearing up my bag. Oh man. Sorry about that. I always tell students, if you see a fiber optic cable, do not touch it. If it's already one in place, do not mess with it. And the reason for that is as fiber ages, as longer a fiber cable sits in place and it does not move, once you put a fiber cable in, you don't really want to unwind it and move it from point to point, because as it ages, fiber or the glass inside the fiber can crack severely to the point where it makes the cable unusable or cause degradation in the cable, where you start losing throughput through it. So I always tell students and anyone that is around it, do not touch any fiber, especially in a wiring closet, because if you touch it, more likely you're going to have to replace it. And that's the easiest way to say. Two types that's talked about in this class is single mode or multi-mode fiber. Single mode, it's a very small inner core, 9 microns in width, and you got the outer glass cladding, which is 125, and then you got the coating around the fiber. Okay, so the SMS or single mode fiber is the most expensive. It sends a single ray of light. It can go long distances, even up to hundreds of kilometers. Normally for long haul telephony or cable TV can be used. Multi-mode, which is here, is larger. You have the 550 to 62.5 microns, still the same 125 microns diameter for the glass cladding, and then the coating on the outside. And instead of a single for single mode, this one path for light, multi-mode allows multiple paths of light to go across it, or multiple communications data streams that goes across. Let's see. All right. Fiber optic. Where do you use it? You can use it for enterprise networks like the backbones, and we do use it in our data center. Unfortunately, I do not have fiber to the home. If anybody does, congratulations. Kelly, he will talk. I promise you, Monday you will hear Kelly talk about he is fixing to get high-speed internet. It's going to be Starlink. Elon Musk does. We finally have Starlink availability in our area. He's going to finally have high-speed internet to his house. He's going to talk about it. I promise you. He just told us yesterday. He's already happy as he can be. So it's not fiber. It's going to be wireless, basically. But fiber is used for long haul networks, and even in the ocean or submarine cable networks to go from location to location or from country to country. Let's see, different connectors. So it's straight tip or ST connectors. Those are basically twist on and twist off bayonet type connectors. Then you have SC. I always say they're square connectors. These are push pull for both multi-mode and single mode fiber. You have LC, which is, I always say kind of long connector. Says these are a smaller version of a SC connector. They're just smaller in size. Here you have the duplex. Now, the duplex is basically two of the LCs together. So you have straight tip that are basically they're separate, and you can kind of have them a little distance apart. Have the square, which they're still separate here. LC is just a single connector, and then the duplex is actually both of the LC connectors in a single dual slot here. Patch cords. Now we have a lot of patch cords in our lab for students to use. Here's SC to SC connector, LC to LC, which is this is dual SC connectors to LC connectors, square or ST to LC connector, and then SC to ST. So it's basically what connectors you have for the device, and again, it shows it's very you can use it for multiple items. Comparisons between UTP and FTP, or fiber, I mean. UTP 10 megabits to 10 gigabits, fiber 10 megabits up to 100 gigabits, and even more now. Distances, the max distance of a UTP copper cable is 100 meters, max on fiber is 100,000 meters. As a high fiber versus copper, highly resistance to EMI, RFI, or electrical hazards. Cost-wise, copper is going to be cheaper on all of it, whether it's media, installation, skills it's needed, and even safety, how to keep it protected. Wireless. I'm sure majority of us in here use wireless at some point in time. Wi-Fi 802.11. You have Bluetooth 802.15, WiMAX 802.16, even Zigbee, which is low power, used for IoT connections. Those would be questions like CCNA would have. What IEEE number does Bluetooth represent? It would be 802.15. Wireless connector, whether it's an access point, wireless NIC, wireless is going to play an important part of it. Here it's using a Cisco Meraki 64W. But it used to be a Linksys they had there, but now because they're doing everything Meraki. Unfortunately, and I don't know why, but Cisco, we can buy Cisco routers and switches, but we cannot buy any of the Meraki devices at the Cisco discount we get for being a Cisco Academy. Hopefully that changes in the future, but right now we can only buy like a 2960 and I think a 40. Now it's a CSR 1000 switch we can get, which are all 1 gig ports, and I think it might have a 10 gig port on it. And then now it's the 4000 series routers that we get at the discount. It's between 55 and 58% discount for equipment. I don't know if Kelly and Mike would talk about it. With the delay in shipping and getting items, if you are planning to have equipment in your classroom, you need to order it 6 months ago, because I ordered stuff actually Kelly ordered a 9000 series switch that we can use for automation, more of the automation side of the CCNA for classes. He ordered it last June, and he still hadn't got it. May have been August he ordered it. And I ordered Cisco some switches and routers, and I just got my routers today, and they were ordered before Christmas. So be aware if you got to order anything, it's going to take a while. For this one, let's see, it's back to here. Mother 4. All right, so you've got 4 packet tracers and 1 lab via NetLab. So what is it? 465 471. All right, so this one, packet tracer here, you check, you understand it's connecting a wired versus a wireless LAN. That's 465. 466 is, don't use this document, use the NetLabs document. This is the lab you will do in NetLabs. And then you have 2 packet tracers, one working with the physical layer and then one connecting at the physical layer. So there's 3 packet tracers and 1 NetLab lab for module 4. All right, Monday, yeah, we will have class Monday. State of North Carolina doesn't cover that, so we will have class at 4 o'clock on Monday. I've got Time Warner, so I don't have to use Starlink unless they force me to do it. How do I know which labs are on physical equipment? Okay. Kind of easy to follow, like module 4 through 7. There's the instructions here. Complete these packet tracers and submit them. And then here, complete these via NetLab, 466, 716, 727, and 737. So each of the modules sections will tell you whether it's a packet tracer or a lab to do in NetLabs. All right, we're right at 5 o'clock. I hope I haven't bored you too much.
Thank you, Brian.
All right, y'all have a wonderful day. Any questions when everybody goes? Okay, we will, what was the first NetLab lab? That one was,
In module 3, right?
yeah, 292 was the first lab you would do, 292. That's fine. It's still best. I mean, even though you've been doing them in packet tracer, Dr. Reynolds, still back up and do them in NetLab, because looking at the real gear and seeing the command line versus looking at it in packet tracer, there is a comparison, and you will notice the difference. Okay. Outside of that, if no questions, please have a wonderful rest of your afternoon. And if you need anything, send me an email, send Kelly an email, Michael. I know Michael and Kelly will be at Cisco until Friday. They come home Saturday and we all leave out Sunday, and we'll be at Skills USA Nationals next week. We will still have class Monday and Wednesday. Okay.
Thanks, Brian.
All right. Have a good one.
Thanks.